Tonight what we're going to be talking about are the reasons why the periodic table has the trends that it does. And what it is it is influenced by two major factors. The first factor that we are going to be discussing is energy level. What happens as you go down a column is you add more and more energy levels. So if you're talking about these trends, first off, what you have to know is it's always about the attraction that the valence electron has towards the nucleus. So what's happening as you go down a column that will affect the attraction between the valence electron and the nucleus? Well, if I look at the first one, okay, the first energy level, if I look at the valence electron, it's located there. If I go down another column or down the row, down, I guess, the column to a new row, you are now on the second energy level, which means that your valence electron is located here. If you go down another one to the third period, your valence electron will be located here. And what do you notice about the distance between these? Well, if I focus on the distance between my attraction of the electron to its nucleus from the first energy level, and then I look at the difference between that and the electron and the nucleus of the second energy level, and that of the distance between the nucleus and the third energy level valence electrons, what you should notice is that the distance is getting further and further apart. So what I like to do is when I'm talking about attraction, I like to think of magnets because we see magnets all the time. And what's happening with these energy level changes is that we are separating our magnets more and more and more. So the greater the distance that these magnets are from each other, the less attracted they are to one another. So what's happening for this valence electron to the nucleus compared to the one in the first energy level? Well, it's less attracted because it's further away. If you want to look at this one, this is exactly what I basically drew on the previous slide, is we've got the highlight of the energy or the valence electrons and which energy level it is. And if you notice, you are going to be having a lot more distance between the valence electron and the nucleus as you go further down the energy levels or more and more periods down. So what that means is that your attraction decreases as you go down the periodic table. Okay, and when I'm talking about attraction, I'm talking about the valence electron to the nucleus. The other periodic trend that we're going to be talking about is going across a row. So you might think, well, what's changing when you're going across a row? Well, what you are changing is because you're on the same energy level, you're basically relatively the same distance from the valence electrons or the same distance to the nucleus. What happens is, though, is your charge, the number of protons and your number of electrons changes. So if I'm at the first group, I've got, let's say, I'm going to go the first, I guess the second period, which would be I'd have 3 protons. So I'd have in that, I'm going to erase this, I have 3 protons, so a +3 in the center, and I've got an energy level here, and I have 1 valence electron on the outside. Okay, then I go over to my next one, and what happens is now I have a +4, and I have on my outside, I have 2 valence electrons. And as you go further and further, what you'll notice is that I'm going to be down here, what your charge happens is you go from a +3 to a +4. This is called your effective nuclear charge, +5, +6, so on and so forth. So your nuclear charge is increasing. Why? Because you're increasing the number of protons. So what does that mean? Well, you're relatively the same distance from each other because you're on the same energy level, but your charge is becoming stronger and stronger of the nucleus. So what happens as you go further and further down, the electrons on these outer valence electrons, these become more and more attracted because your charge in the center, your nuclear charge, becomes stronger and stronger. So what I like to think of it as is this +3, okay? Their charge is kind of like those free magnets that we get in the mail. Okay, so yeah, they're attracted to each other, the nucleus and those electrons, or the two magnets that we got in the mail. They are attracted to each other, but as you get further and further, you're getting to higher end magnets, to where if you're at the very last one, what you'd be getting is what I call a cow magnet. What is a cow magnet? A cow magnet is actually a magnet that farmers give to cows, and they ingest it. They have 4 stomachs, so what happens is these cows that are not very bright, they eat everything in the field, which includes nails from fencing and stuff like that. So they'll eat these nails. Well, if it went through all of their digestive tract, they would end up dying and bleeding to death. So what the farmers do is that they give them a cow magnet, which is extremely strong in the first stomach, and it collects all those nails in the first stomach so it doesn't go through the entire digestive system. So those are extremely strong. So that would be here. If you put two cow magnets together, good luck trying to get them apart. They are so attracted to one another. Okay. So if I look at what happens once again across a period, this was the one I was describing before. You look at it and your nuclear charge gets stronger and stronger. So the electrons become closer and closer because they are more attracted. So here is your cheap magnet. Okay, notice that they are not that far from one another, or they're relatively far from one another, whereas this is the cow magnet. They have an extremely strong attraction to each other, those electrons and the nucleus. All right, so once again, going over the summary of what you should have known today or learned today, as you go down a column, what you're doing is you are adding more and more energy levels. Therefore, your attraction becomes less for the electrons, for the valence electrons to the nucleus. The opposite happens as you go across a period. As you go across a period, the attraction increases. Why? It's because of that nuclear charge of adding more and more protons. All right, have a great evening.